Our next speaker is Dr. Amanda Hale, an associate professor at Texas Christian University. Amanda has worked extensively on wind energy impacts to birds and bats, and in that capacity, she's a science advisor for the American Wind Wildlife Institute, that Tabor Allison's affiliated with, and we'll see him next. We've given Amanda a near impossible task, which is to summarize what we know about wind energy impacts to all the other birds besides eagles and sage-grouse, to bats, and to habitat. You have 15 minutes. Good luck.
All right, well, good morning. Thank you for the introduction, Nicole. It really is a pleasure to be here today. And I do feel that I have an impossible task, so let's see what I can do about that. There we go. So my background is in ecology and conservation biology, evolutionary biology, thinking about animal behavior and how that might impact some of our conservation strategies. But back in 2008, my lab had the opportunity to join this partnership with NextEra Energy Resources and really take a comprehensive look at wind. They essentially opened their doors to a wind facility in north central Texas, and together with my students and collaborators, we've been looking at the direct and indirect effects of wind turbines on birds and bats for nearly 10 years now. So rather than go into the details of the studies that we've done in Texas, my thoughts today are really to talk about broadly, what do we know about the current impacts to birds, what do we know about the current impacts to bats, and then what are some of the potential mitigation strategies, things that have been employed, and some things with technology that are coming down the future, and then if I have any time, maybe some research recommendations, things that would be relevant broadly across North America, but also here in Wyoming. When we think about the impacts to wildlife, generally we put these into two buckets. One of those are the direct impacts and the other indirect. When we think about direct, we're really talking about habitat loss and collision mortality, so birds and bats colliding with the towers or the rotating turbine blades. When we think about these indirect effects, they're kind of harder to quantify. These are challenging studies, but the idea, especially as we continue to see wind energy development continue, the thought is that indirect effects might actually become increasingly important, and I'm thinking about how these facilities contribute to habitat loss and fragmentation on a bigger scale, how migratory paths of wildlife can be disrupted, displacing of wildlife from otherwise suitable habitat, and altering things like nesting success in some of these grassland or shrubland birds in particular. As far as impacts to habitat go, this is my one slide. I think we might get to reducing impacts to habitat later on with mitigation. But we know that habitat impacts vary widely from site to site, and it really depends on where that wind facility is sited in the landscape, whether it's in relatively undisturbed habitats or in agricultural lands, for example. Turbines, however, they're typically located about 5 to 20 rotor diameters apart. So the turbines and their associated infrastructure, the roads, the substations that might be constructed really occupy a small fraction of the total wind facility. There was a recent study by NREL that showed that less than 3.5 acres per megawatt are disturbed during construction. And then finally, once those facilities are up and operating, it's less than 1 acre per megawatt are disturbed permanently by roads and turbines. And the nice thing about it in many cases is the land around the turbines can be used for a wide range of activities. And I know this is important in Texas, where you have turbines situated on almost exclusively on private land, and then ranchers continue to use that land, farmers, as they did before. Okay, so what are some of the impacts to birds? Well, we know that birds fly into things that people build. They regularly do that, and collisions with wind towers are no exception. Collisions have been documented globally. There are about 170 studies conducted in over 100 wind projects with data that are publicly available just from the US and Canada, and these studies report fatalities for about 250 different bird species. The studies where we have these data are not a random sample of all wind facilities or even of wind turbines within a single facility, so what we really don't know is, are the publicly available data actually representative, and do they give us a good picture of what's occurring? If we look at the overall fatality rates, for bird fatality, it's about 3 to 5 birds per megawatt nameplate capacity per year, and this is for all species combined and adjusted for some of the detection biases that we encounter in these studies. Overall, what's been shown in the US and Canada is that songbirds comprise more than 60% of the turbine fatalities, and we see fatality peaks associated with spring and fall migration when large numbers of individuals are moving across the landscape. Diurnal raptors are also frequent fatalities, and it's thought that this could be due to their flight patterns and their hunting behavior, and I think we'll hear more about that from Tabor Allison in a little bit. And really, we're most concerned, though, with species that have small population sizes, delayed maturity, and long lifespans, and collectively the cumulative effects are unknown. So we don't know what the impact's going to be on populations as we continue to develop wind. There have been a couple, though, of nice sort of meta-analyses that have been done to show how many birds are killed. This is just one example of the several that are out there in the literature. This is by Scott Loss et al., and they included 68 studies of bird fatalities at facilities that only had the monopoles, so the solid tower structures, and they estimate that about 140,000 to over 300,000 birds are killed with turbines in the U.S. each year. And that panel over there on the right shows an increasing trend with bird fatality with turbine height, which you can see over at that 80 meters, which towers are now 80 meters if not taller. There's tremendous variability in bird fatality from site to site, even with the same kind of turbine technology. And then the lower panel in the graph just shows there's some variation among regions, with perhaps California having some higher fatality, and then the Western Plains having lower fatality. Another example, restricted though just to songbirds, so how many of these small passerines are killed. This is by Erickson et al., and they included 116 studies from the US and Canada, both with the lattice and the monopole turbine towers, and their estimates for songbirds are in that over about 130,000 to 230,000 songbird fatalities per year. One thing they did is they broke it out by biome, and they found that fatality rates do vary by biome, with lower fatalities in the plains. And then they also, I thought, did an interesting study where they compared fatality rates by species to our estimates of population sizes. And so the highest sort of take from wind turbines was actually the black-throated blue warbler shown here, and the estimated population effect was 0.03 to 0.04% of the population size per year, and that was the highest number. And so the conclusion for many of these studies is that yes, the songbirds are being killed at wind turbines across North America, but it's thought that the sort of the take on the populations is very low and does not threaten population persistence. If we put this into context with other sources of anthropogenic mortality in birds, a nice study looking at collisions with building estimated these numbers in 365 to 988 million birds killed annually just in the U.S. If we think about our free-ranging cats, it's not a pretty picture. 1.4 to 3.7 billion birds killed annually just in the U.S., and then collisions with communication towers are certainly a concern. So 6.8 million birds killed annually. And so the collision mortality from other anthropogenic sources is really orders of magnitude higher than what we've seen in many, many studies done in the US and Canada. So that's kind of, I'm going to leave the direct effects on birds. And as far as indirect effects, in the US, the focus has really been on these open habitat adapted species. So things like prairie chickens, grouse, which you just heard from Chad, and grassland birds. Most studies to date have looked at displacement or avoidance from wind turbines, but increasingly we're getting data on breeding performance, adult survival, nesting success. The trick is, the pattern appears to be that there really is no pattern. Responses appear to be species-specific, season-specific, site-specific. The mechanisms for some of these impacts are not well understood. And we also have this additional challenge of high site fidelity, so species perhaps attempting to continue to breed in habitat that's no longer suitable, as well as the flip side is that there's a potential for habituation. And again, these cumulative effects remain unknown. With these greater prairie chickens and greater sage-grouse now, as we know from Chad's study, there was real concern because these species are sensitive to disturbance from roads, utility poles, transmission lines, etc. And so with the advent of wind, there was real concern that these species would be severely negatively impacted by wind development. And thus far, in greater prairie chickens and sage-grouse, as we've just heard, the responses really are mixed. We've got negative, neutral, and positive responses, and really need to be thinking more comprehensively about how we can develop wind in a way that facilitates the persistence of these kinds of species. Okay, so shifting now to bats. What do we know about impacts to bats? The biggest concern with bats really is collision fatality with wind turbines. In the United States and Canada, most observed fatalities are migratory tree bats, and 78% of all observed fatalities are really comprised just 3 species: the hoary bat, the silver-haired bat, and the eastern red bat. So these are tree bats. They make long-distance migrations across North America. They have a solitary lifestyle, and part of the challenge is putting this fatality into context. So, for example, all the other bird fatality, we've recorded over 250 species of birds being killed at wind facilities in North America. Bats, thus far, it's these 3. Although other bats we're finding them at facilities as we continue to expand into new habitats. These are a couple of the estimates that have been published to date. So Arnett and Bayerwald did a survey of cumulative bat fatalities over the past from 2000 to 2011, and their estimate is about 650,000 to 1.3 million cumulative bat fatalities. And then Hayes' study, he reported about 600,000 bat fatalities in 2012. So there's some disagreement about Hayes' paper and some others, but I think collectively there's increasing concern that this anthropogenic source of fatality in bats is a real problem. Bats don't tend to fly into other things that we put up in our airspace. We don't find large numbers of bats beneath our buildings. They don't typically fly with cars very often, although that happens as well. And so we're really concerned to think about what this might mean for these 3 species in particular. There was a nice study this year published by Frick et al. Been showing that the hoary bat, given current development, current deployment, no more wind, there's a high probability that that species will be extinct within 50 years if we continue to operate turbines as they are now. One of the things that's happening with bats and that's different from birds is that there's increasing evidence that bats are actually attracted to wind turbines. And so if you go out and build a facility, you're going to end up observing bat fatality. So these attraction hypotheses can be broken down into 3 categories that aren't mutually exclusive. It could be that wind turbines provide one or more resources for bats. It could be that bats misperceive these turbines to be a resource and they're spending more time at them. And then third, bats are mammals, they're curious, and they could just find some aspect of wind turbines intriguing, and they come into these towers, and then they are at risk of colliding with those rotating blades. With advances in technology, there are several research groups that are observing bats at turbines using thermal cameras and infrared lights, night vision scopes, and these videos show bats exploring and contacting the non-moving parts of turbines, so the monopoles and the nacelles, as well as those turbine blades when they're not moving. And these flight patterns are suggestive of a whole different range of bat activities. They indicate that bats are actively foraging at wind turbines, they're investigating the structure for roosting opportunities. The flight patterns are also things that we also see in mating behavior in hoary bats, for example, and we also see these bats approach the tower support structures as if they're trying to drink from these wind turbines. So as far as how can we reduce these impacts to wildlife, we've got really 3 different strategies. One, we can be thinking about at a pre-construction phase, so what can we do with risk assessment and siting to minimize the potential for conflict. The second thing we can do is look during the post-construction phase, so really evaluate the impacts and then test and implement effective mitigation strategies. And then third, which is beyond the scope of what I'm going to talk about today, but we could devise new and improved regulations to protect our natural resources. So with risk assessment and siting, we've got 2 choices really, macro siting or micro siting. With the macro siting, it might be something like avoiding core areas for species at risk or encouraging and incentivizing wind energy development in already disturbed landscapes. Micro siting is more dealing with individual placement of turbines, and so we might be avoiding a particular resource, whether it's a maternity roost for bats or a golden eagle nest or something like that. The effectiveness of micro siting is not well understood, and it's largely untested as well. Especially when we think about trying to predict risk to bats in a pre-construction phase, to date, it's really been hard, and I think that attraction might help explain why predicting risk to bats has been unsuccessful. So the panel over here it was tricky, on the left-hand side of your screen, on that y-axis is bat fatalities per nameplate capacity megawatt, and on the x-axis is bat activity recorded as the number of bat passes per detector night. And these are data from 12 wind farms where we've got pre-construction bat activity data and post-construction fatality data, and the slope of that line is not different from 0. So whether you have a lot of bats or a few bats prior to construction, it doesn't seem to predict fatality. And then over on the other panel are data from 29 wind farms where there was an ecological impact assessment done. These are data from the UK, and the sites were broken into 2 categories. Those with the low perceived risk to bats, those with the high perceived risk of bats, and then the data from post-construction fatality showed no difference between the sites. So right now, this pre-construction predicting risk to bats is problematic, and we maybe need to be thinking about something else. As far as strategies to minimize fatalities for birds, one that could potentially be successful is repowering, so replacing several small turbines with fewer larger turbines, and this is particularly important in sites like the Altamont Pass, where fatality rates for raptors and for all birds could be significantly reduced by making these repowering changes. The other thing that we've seen implemented is selective shutdown or curtailment. And so another place in the world where large numbers of raptors are killed are at wind farms in the southern part of Spain, in the Straits of Gibraltar, and selective shutdown of high fatality turbines has reduced griffon vulture mortality by 50%. So that's a strategy that can be implemented. And then I think we'll hear in a bit from Tabor Allison that right here in Wyoming, there's questions about golden eagle fatalities at the top of the World Wind Power Project. Several measures have been done to try to reduce fatalities, such as removing carrion and looking at radar technology to detect eagles. But currently, there's studies underway to look at human observers and also camera systems to try to evaluate, detect eagles with risky flight behavior and shut down individual turbines to prevent mortality. As far as current mitigation strategies for bats, we currently have two that are options. One is siting restrictions, so limiting where wind facilities can be built or providing setbacks from important bat habitats. But again, with this attraction of bats to wind turbines and the species that are impacted traveling across the continent, it's really hard to think about how these might be widely applicable and useful. The one strategy that has been very successful is operational minimization, which is often not popular with wind energy developers, and that's limiting power production by limiting wind turbine blade rotation on low wind speed nights. Where this has been tested at facilities in the US and Canada, bat fatality rates have been reduced by 50 to 93%. The downside with both of these options, though, is you're limiting wind energy production, and so there's a real desire to improve mitigation strategies for bats, and they really are taking two avenues right now. The first is to refine this operational minimization, so to go in with more of a razor blade approach and really target when bats are active in an area, so to look at not just wind speed, but other variables such as temperature, wind direction, to try to fine-tune that curtailment, and also using real-time acoustic monitoring on wind turbines themselves to know not just with these correlates of weather variables, but if you've got bats actively echolocating at turbines, shut them down under those conditions. Regional weather patterns are some other options. The other area, as flip side to that, is to try to look at technology and invest in technological solutions to reduce bat fatality. Right now, there are about 4 research groups that I know of in North America that are testing acoustic deterrence. And the idea is to put up devices on wind turbines that will broadcast ultrasound to deter echolocating bats from coming into the area. So to make a noisy airspace that will prevent them from colliding with the turbine towers and blades. Another option is to use dim UV light illumination, and the idea here is to try to change how bats see wind turbines on a landscape. That has not been tested, but it's certainly a possibility. And then one thing that my lab is doing, which is a texture coding for wind turbine towers to alter how bats are perceiving the surface and interacting with them. This is just showing the Bat Conservation International. Those are the small devices up on the nacelle. They're currently working with NRG Systems and 3 wind energy partners, and tests are underway this year at 3 facilities across North America, and they're looking at the effectiveness of these devices. They're using thermal cameras to watch bats and also monitoring fatalities, and what they predict to see is a reduction in bat fatalities when these devices are operating. And then one thing that my lab is working on, support from the DOE, is a texture coding development that involved, along the way, we brought wild-caught bats into the lab, we looked at how they interact with a range of surfaces, and we're now watching bats at turbine towers. So we put up texture coding, you can see there in the gray area, and then when you get the top coat on, it's white. And my students are watching bats at smooth towers and texture towers to see if we can reduce the amount of time they spend investigating these structures to hopefully reduce fatality. And so, very quickly, some research needs and recommendations. We need improved estimates of collision mortality. We really don't understand the biological impacts or significance of some of these impacts, and we need an unbiased estimator and standard reporting at many facilities. We definitely need risk and improved risk assessment, and testing models that have been proposed is something that needs some more work. Continued investment in technologies and effective mitigation strategies, and we really should be focusing on species or populations of most concern and trying to get at the mechanisms for these adverse impacts. What is it about their ecology or behavior that puts them at risk? And then lastly, promote coordinated research efforts, encourage multiple stakeholders to come together and work together to minimize these impacts, And then probably last but definitely not least is that the data from these studies must be publicly available. We need to share results, and that way we can all benefit from the research that's being done at wind facilities across North America. And if I have time for questions, I'd be happy to answer those, and I'll certainly at the break, I'm happy to give more detail about any of these studies.
Thank you. Very great presentation. Two questions. One, is there some studies as far as shutting down or minimizing the wind turbine operation right after dusk? So it seems like bats are really active. And then is there any studies on long-term effect, like the second or third or fourth year bats and birds learn to avoid the towers?
Sure. Great question. Thank you. Yes, the curtailment for bats, it usually is initiated, it varies from study to study, but 20 to 30 minutes prior to dusk to get that peak bat activity in those first 3 hours when they're out foraging. And then it continues throughout the night until just after sunset in most cases. There are very few sites that have multiple years of post-construction fatality data, but Erin Bearwald and her colleagues are working on some data right now, and what they are beginning to see is a decrease in fatality from 1 year to the next. What we don't know, and probably think is there aren't learning opportunities for bats here. When these blades are moving at such high rates of speed, bats that come into contact with them are killed, and so learning doesn't seem to be possible in this instance. So no habituation, that sort of thing. But the data suggests that fatality rates, if you look from year 1 to year 2 or year 3, tend to decrease. And what we don't know is, are bats moving away from those areas? Are they finding other migratory routes? Or have we simply killed enough bats that we're seeing lower numbers? Both of those are possible.
Thank you so much. I was wondering, you presented a slide earlier that showed the progression of bat fatalities with the height of the wind turbines. And you said that the wind turbines have the same technology, and I assume that means the same radius of rotors up area. And I was wondering if there's a reason in the actual wind development of those facilities, or that those specific turbines are at higher altitudes or higher turbine heights than others.
Sure. So the slide actually showed bird fatality with turbine height, and what's happened from the late 90s through the 2000s to now is that as turbine technology has evolved, the towers have gotten taller and the blades have gotten longer, and so we get increased power production. And the thought with that relationship with birds is you're sampling a greater area, and if birds are sort of like a stick model just flying through, not attracted and not avoiding, you're going to have higher fatality rates.
We'll do one more question right here. We do have time for one more question. I know a lot of this data is national, and I'm wondering what your research, what the implications of this bat research is specifically to Wyoming, and how common these bats are here, and what their migration patterns are in the state.
Sure. We know from chemical signatures, so there's been some stable isotope work done in terms of where bats are growing their hair. And it looks like hoary bats in particular, we've got the spring migration that comes up the eastern side of the Rockies. There's data out of Canada that shows bats are moving from the east to the west into the Rockies and then moving south. And so I think there's great potential for these tree bats to sort of be funneling through this part, through central Wyoming and then down into Colorado, the potential for fatalities there.